My name is Casey Dernberger. I am the CT coordinator for Missoula County Public Schools. Career technical education consists of 5 program areas: agriculture, family and consumer science, business, industrial trades and technology, and health science.
So what grounds all of this work is that we want to ensure that each and every child is college, career, and life ready. And what we mean by that is that we want to ensure that they have the technical skills, the employability skills, and the academic skills to be productive, viable citizens in our community.
I'm Brinley Mudd, and we are in MI, Medical Interventions at Big Sky High School. So we started with just like regular agar, and we added in some antibiotics into it, and then we put in a special gene that is going to make it glow. And right now we're just observing to see if there's growth in the plates and to see if the gene worked.
If they glow, it means we've successfully added a P-glow gene into the genetic code of the bacteria that we hit with a heat shock.
That one grew.
This one grew.
This one has LB plus an antibiotic. It killed everything, which means that you don't have a plasmid that's giving it antibiotic resistance.
I'm Jessica Tuberty. I teach medical interventions, which is the 3rd year of the biomedical strand for Project Lead the Way. My course is a unique blend of microbiology, chemistry, and genetics. Most people never get to do a transformation experiment until they're at the university level. These are juniors in high school, and that's because the district and the community has provided funding for our program, and we're able to do these high quality labs year after year after year.
Wow! I mean, by far the best. Yeah, so if you flip it over and shine a light, so your efficiency is going to be great. Maybe even as good as like a factory, like a biotech facility. These are glowing E. coli, and so this process is called bacterial transformation, and we have placed some new instructions inside the bacteria through the process of heat shock. And it proves that you could do genetic engineering in a high school lab. Cutting edge.
We're working on making a foot orthosis, or a model of foot orthosis, to help people with cerebral palsy. We all came up with our own ideas, then kind of merged them into one. Now we're gonna start building.
So you've got string and everything else.
We're gonna have Velcro straps here, and when it says pads right here, it means that the pads are gonna be inside, so it's more comfortable. It's hopefully going to be helpful and comfortable, and it's easy to take off because you just slip your foot out.
So the Velcro would be more around it, like that, and then the 2 pieces of cardboard would be like this.
My name is Scott Edge. I'm at CS Porter Middle School, and I'm teaching design and modeling to 7th graders. They're working on an AFO, or an ankle foot orthosis. So they're working in teams to build this for a young child who has cerebral palsy. So the goal is to create a walking boot that keeps their foot at a neutral position and doesn't allow them to go down to their tiptoes, but does allow them to go up if they need to. One of the things I like to see the kids do is use the math and use the science that they come into my class with and apply it to something like building a foot orthosis. It makes it more real world. It makes engineering more connected to them.
My name is Naya. My name's Madison. Hawthorne School, Mr. Williams' class. We're working on our brain model, and right now we're doing the senses and the nerves.
So we've been learning about the brain and looking at ways we can model the brain as a system that receives input through the senses, and then process that information up in the brain and then send signals out to other parts of the body on what to do once they've processed that information. We build a central nervous system out of clay, so the lobes of the brain and then the spinal cord. And then today we're adding in the rest of the nervous system that receives the information and sends it to the brain and then sends it back out to the rest of the body.
In this class, we build stuff and we test things, and then in other classes, we more have learned things about stuff and just do a little writing about it. I think this way you can see it better, and you get a better interest in it, and you can touch it.
In the past, when I've done stuff with science, sometimes it ends up being a whole list of vocabulary words. For this one, like they might have to define the parts of the nervous system. And they might have to explain exactly which lobe receives what information from the brain. Whereas here, they don't have to memorize that information. They have to use it in a meaningful way. So they're showing where the body's getting information from using yarn, and then they're mapping it all the way through the body with that yarn to a specific part on the brain. So they don't have to memorize, that the sense of smell goes to a certain lobe in the brain. They show it using their model.
We started there, and it said it touched a pillow, so it went up to the parietal lobe, and it said sleep. And then it went back to the feet, and it said walk to bed. And then it found it had water on its nightstand, and it drank it, and it went up to the mouth, and now it's heading to the parietal lobe.
One of the really nice things about the next generation science standards that we're using is they're really explicitly built to spiral back through the grades. So the things they're learning now about energy or about the brain as a system that receives information, they'll apply that again in 7th grade or in 8th grade, but on a different level.